All right, we're gonna try advent of code day 2. I did not get part 2 of day 1 done. I was really banging my head against the wall on that one. For some reason, it shouldn't have been that hard, but I just couldn't figure it out, so I had to kind of call it quits on that. But yeah, let's give day 2 a try. Now, day 1 I had a lot of, because I'm doing it in C, and obviously with C it's kind of a pain, because with Python, you know, the input and the regex parsing and all that stuff is a lot simpler. With C, that was honestly a good portion of the challenge, so I'm going to try to use these functions that, like I had this parse line that output a struct that contained kind of the data necessary for the problem. In this case, for day 1, it was the direction and distance of the dials, which are called a dial entry. And then I had get lines from files, which just returns it populates this function argument, this array of strings, things like that. So I'm going to try to copy some of that over, and I really should just make like a utils file. But I don't know in C, there's probably not a way. I'm not super familiar with like templates and stuff. Templating, I don't know how to pronounce it. In like C++, but I know it's a thing, and I think that'd be something that would be useful for something like parse line, where I want to return a struct that's relevant to the given day's problem, but I don't know how to do that in C. So for now, just to make progress, we're just going to copy and paste and see how that goes. So we need I need to change my keyboard settings. Okay. So let's grab the parse line and the get lines from files functions. Oh. Okay. So let's read the problem. You get inside and take the elevator to its only other stop, the gift shop. Have you even checked most of the product ID ranges already? They only have a few product ID ranges. Your puzzle input that you'll need to check, for example. So these are product ID ranges. They appear as a single long line. Okay. Each range gives its first ID and last ID. Since the young elf was just doing silly patterns, you can find invalid IDs for looking for an ID which is made of only some sequence of digits repeated twice. So 55. Wait. You can find the invalid by looking for any ID which is made only of some sequence of digits repeated twice. So like, oh, that's gonna be fun. So like, I guess I can just see which ones are invalid. So 11 through 22 is wrong because 1 was repeated, 2 was repeated. So there's a single 1 make it invalid? So if it was like 11 and then to 21, would it be invalid because of the 11, I assume? Let me just go through and see without looking at the answers to kind of determine which ones I think is invalid. Okay, so based on what it just said, let me try to mark out which ones seem invalid. So 11 through 22, so this is repeated, it's invalid. That has a repeated, invalid. Repeated invalid. See, I don't think that's what it is, right? Is it if the entire does the entire number have to be kind of repetition? Because in that case, like all of these would have some repetition. So I think I'm doing that wrong. So okay, because it's not gonna be all of these. Wait. Oh, it's the actual range. The range has invalid ones. Okay. So it's not just is the range overall invalid, it's how many invalid values exist in that range. Interesting. So 11 through 22, you know, would be, for example, 11, 12, all the way up to 22. I'm assuming these are inclusive. This one's invalid, this one. Okay, interesting. So you have to do the actual entire. Okay, that kind of makes it somewhat easier. Well, not really. Not really at all. It's kind of the same problem. Okay. So really what we want, I think kind of the workhorse of this problem is going to be one second. The kind of the workhorse of this problem is going to be a function that takes a number and can determine is this invalid or not. I can take this number, say is that invalid or not, and that will be really that's going to be a pain to do in C, because it's really just like string parsing, right? But we're gonna try our best. Interesting. So I almost want to start with just getting the input parsing done, honestly, because that seems like a much easier problem to solve. I will kind of want to procrastinate actually solving the problem because, you know, that's going to be challenging. So let's just do that. Oops. Okay, so instead of a dial entry, how do I do this? There's a struct there. All we're really going to need is two numbers, the start and the end. What do they call this? Product ID range? A struct isn't really necessary, but let's just do it to kind of keep it consistent with how much I'm going to do the rest of these problems. Product ID range. And I hate little abbreviations like this, but that's going to be easier. It's pretty self-explanatory. So we have a line. Well, in this case, we don't. The entire input's a line. Let's also get our input going. Input to /short.txt. So in this, it'll be a little different because we're not parsing line by line, because the entire thing is supposed to be a line, right? Wait. Let's just grab our puzzle input as well while we're here. See, that actually is a single line. Okay, cool. So we're not parsing a bunch of lines. We're parsing based on commas. So let's say instead of get lines from files, let's do get product ID ranges from file. So same kind of idea there. Let's figure out how this works. Wait, if I'm over here and I close this, interesting. Okay. I should get IOC on this, that font. That's okay. Actually, let's not do it right now. Maybe I should horizontal split. Okay. So did I have the font? Okay, let's see. Whoa, what is happening? Oh, that's my YLO. Okay. Sorry, confused for a second. So we have our file. We open the file. If the file doesn't open, do that, and then go as long as f. So f gets is based on. What I really want to do is f gets delimiter. Parse. There we go. Comma separated string. I figure string token is probably useful here. I don't quite remember how to do that. Okay. So we have this string pointer equals that. Okay, let's just rewrite this function here for the most part and comment it out so we keep it around. But we open the file, and then well, let's just open a sandbox. Okay, probably definitely gonna do this for longer than 15 minutes like I originally planned, but that's okay. So if we have our string, let's just do like their example here. We have a pointer, points to the first, or let's put that because that's used in the string token string token call. String token. So passing the string, and then what we're searching for, what we're using as a delimiter, I guess. And while our pointer is not null, we'll grab a number, a to I. What is a to I? What is a to? Oh, I should probably make sure my camera's not blocking too much. Oops. Okay. So a to I is ASCII integer. Okay, character int. Cool. So we grab the. So what is string token doing? What is stir toke doing? So we increment the pointer by doing the next one. Mess up the string you feed it. That should be fine. It will write finds a token you supplied and returns a pointer to the start of the string. Oh, interesting. That's why I was wondering why they did an array. So if I try to run this, Is it because of this? Interesting. Okay, cool. Okay. Now let's say if instead we had something like this. Then it's pretty much saying it's parsing. If we're here, okay, we're gonna parse. We've gone, I guess, up to this point. We're parsing this into a string or into a number. Cool. Next one. So it's taking only the first number. That makes sense. So we want to do instead. So if we do it twice, that's not going to be what we want. I'm wonder if this parses as a negative. Not that it really matters for me, but I'm just curious how it works. Because A2I is not gonna. That's not gonna do what I think it's gonna do in any capacity. Yeah, that makes sense because the token's not moving. So when I just call A2I twice in a row, it doesn't move the token along. Now, could I just simply do that? Yeah, okay, that does more what I thought it'd do. That does more what I thought it would do. So I keep splacking and I keep pulling something out that I don't want to record. The problem is, you know, when numbers are really big, let's again make it work for simple cases, then make it work for more complex cases, and then make it clean. Right? See, this is the beauty of C. We're 18 minutes in, and I'm still figuring out how to parse the input. But it's good practice, I think. Well, we could just consume. How to consume? Really what I'm going to do is these substrings like this is its own string that needs to be kind of parsed. So let's say, what if we made a function parse range? So we'd want to take that string make a pointer, that's the thing, how do you just increment the pointer by 2? Does that even work? Let's see. Does it even compile? No. If I was to do, let's say, char string, well, this is fine. We can use this string up here. See, it's not gonna work because we're doing like. Does it work if we do this? No? Interesting. Why does that not work? We're not incrementing the pointer correctly. So that's the problem. We're just doing +2, but that's dumb. That's dumb though. But what's a better way to do that, right? That's kind of the problem. What a pain. What a pain. That's the thing. I don't know. Yes, it's a cool. I don't know. I don't want to talk myself out of doing it in C, but the biggest challenge is the string parsing. It's like by the end of all this, I'll be a freaking expert. I'll be a wizard in string parsing in C, but is that worth it? I don't know. Could almost solve the problem in Python and then go implement it in C. I'd be probably less motivated to do it at that point, though. Let's be real. Okay, well, let's think about this for a second. Let's let you understand what's going on with this string toke. Because the thing is, this might never be null because we're incrementing by 2, and it's dumb to increment by 2. Well, I shouldn't need I shouldn't need increment by 2 because remember we're parsing a string that is okay. Multiple mistakes here. One, that's not what our string should look like. It should be a single range. Still an issue, but I expected that. And remember up here, we don't need to do this +2 because again, our string is simply a range, number dash number. So we should have the strtoke incrementing logic, and then that works. Well, it doesn't work, but it doesn't get a segmentation fault, which is dope. The problem is here. Well, the problem is we're doing both times. We need to kind of have a condition that checks, you know. Just have it start as -1, and then if start equals -1, then we'd say start is that value. Otherwise, start's already been initialized, so we'll do end instead. And that did not work. If cool, there we go. Let's test if it works with bigger numbers. It does. Awesome. Cool. So let's do the parsing our range, which is dope. That parses a single range. And then this logic here. So our string is, what's the thing, if we print out pointer as a string, although we probably don't want to do it like that, we probably want to do it like this. And let's just not do any of that or any of this. Right, it has all those individual strings. Because, again, what's happening, based on that quick Stack Overflow answer I saw, you have a string like this. When you're doing stir toke, a string, and then a delimiter. I guess it would actually be a comma. What it's doing is saying, I think what it's essentially doing is going in looking for the comma. Okay, we found a comma. Great. Let's replace that. Let's replace that with a null character. So then when it prints a string, it's just this. And then it knows, I guess it, and then, oh, okay, is that must be, okay. That's why we then do this stir toke null. Wait, no, that's not right. This must be a special thing that tells it, like, hey, go find the spot that we last inserted the null character. Because it's still using this as a delimiter, but this tells it to do something different. I don't think this is saying the null character necessarily, because again, this is the first argument, which should be the string. So how does that work? Those are splitting a C, an null delimited string into tokens separated by any delimiter you specify. The first call must pass the string, subsequent must specify null, which tells the function to continue tokenizing the string you pass it first. So that, it's kind of just a special thing that says, hey, keep going along. There's going to be stuff under the hood that, you know, of course implements that to do it that way. But that's what's happening. That's why when I print it each time, it's only here. And then the stir toke null call kind of moves us on here, and you know, this is in that, and so on and so forth. So I kind of understand that. Cool. All that to say, though, let's parse. What do we call the parse line? What would you call that? Parse. Let's just call it parse database. So let's just say that's a parse. That's a database string. So we're kind of just copying the code we have in the main right now. Now, question though, as far as what stirtoke works on, if I change this to a pointer, does that no longer work? That still works. I guess if it's passing as an, if the original thing is actually allocated like this, then we're fine. Because if I change this, yeah, so if I change this to that, we'll get issues, of course. Cool. So we have our range. Our string is our range, right? Because our pointer is our range. Because the pointer, let me map this out again. So again, our original, let me undo some of this. Here's our original string. You know, this is our original string. Our pointer points to the start of our substring, and then the stirtoke logic replaces that whatever delimiter. with a null character. So then when we're passing this substring in to our helper function parse range, it'll only really be parsing this string. And then when we do strtoke null down here, this line, we're then moving pointer here. And then we're also replacing this comma with a null character, and so on and so forth. It repeats that process. Right. So then when we take this and pass into parse range our pointer, I believe that just works. We need start and end, which is fine. Right now we'll just do a simple start and end and just print it out to make sure it's working, but otherwise we would probably need an array of structs that contain both the start and the end. Something like that, and this will print it out, and then we also need to increment. Let's see if that works. Okay, so we need to actually call that function. Get rid of this. No. So we'd have, we just need to call our parse database pass in string, question mark. No, that doesn't work. Why does that not work? Why does that not work? Parse database pass in the string. What's the problem here? Why are we only doing that? Oh, because the problem is we're passing in pointer, which is then messing it up. Okay, so here's what's happening. Pretty sure. So we're passing in. Let me put this kind of right here. Okay, so here's what's kind of happening. Oh, I don't. My color is visible. Okay. So this is our original string here. We're tokenizing it, so we're turning this first comma into a null character. We're then passing in this string of 1-2, the null character, of course, at the end, into parse range. And I obviously can't draw over that. So we're calling parse range, PR, let's call it that, here, which is then tokenizing itself, or kind of tokenizing again, so that this becomes 1, the dash is replaced with the null character, 2, and this is then tokenized and used, right? And then we're able to extract out the 1 and the 2, you would think and hope, but it seems like that's not the case, because it's not actually getting passed out. Because if I just pass in, if I just do parse range, Let's just do 1, 2, and then we have our start and end. Oh, that's actually doing the same thing. Interesting. Why is that doing the same thing? Huh. So it was working earlier, wasn't it? Did I make some change to it and not realize it? Oh, these are not initialized to -1. Okay, so I was misunderstanding what was going on the drawing pad side over here. So that was not correct, but hey, we tried to break it down. Okay, so I need to remember to initialize those numbers to the value that I have kind of designated as the value indicating that things need to still be changed. So again, this is not even a long-term solution here. I just want to see if the first kind of attempt works. Okay, start 1. Okay, yeah, that works. So now we want an array of, let's just make it simple and just say an array of, I don't even know, I mean, let's just do 128. Each one is 2 elements. Range is index. So we'd parse the range. We'd say range is the current index. 0 equals start. Well, that's fine. Equals end, and then we'd reset start and end to be -1 to be designated again, right? Okay, we're still only getting 1 though, 1 output. Now that might be similar to what I was saying, something about the whole string kind of getting messed up. So here's the thing. One way to kind of do this is to kind of debug what the actual contents of string is. Of course, you can't really use printf for that, because if you're inserting null characters and that's causing the issues, you can't print it to then see what the null character layout looks like. So we would need to write code to maybe write a helper function to print the entire contents of a string of a given length, even null characters. So let's do that real quick to see if that will help. Print hardcore. So we'll take a string and we'll take a length. If that guy equals the null character, we'll print like that. Otherwise, we just print the character. Let's see if that works. So we can get rid of all this now. The idea is if I had a string that said hello there, and if I know that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and I should be able to print this. Okay, exactly what I wanted. And then let's throw a new line at the end. So that way we can actually see where the actual null characters exist, excluding the actual final one. Because if we were to just normally print this, it would just say hello, right? Yeah. Cool. So now we can use that to debug what's going on here. We can use it to debug what's going on here. So each loop, let's just print hardcore database string. Oh, sure. The length of it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that null character gets placed there, which makes sense because we're replacing the first comma delimiter with a null character, which is how strtoc works. The problem is, if we print it right after, do we have another one? Does it look kind of weird? Yeah, see, which again, that makes sense because, yeah, that makes sense. It's kind of what I was saying earlier. You have this string, you go through, you find the first delimiter, replace that with the null character. We then pass this substring in to parse range, which is then using the minus as the delimiter. So this becomes 1 null character 2. So then that still is modifying this overall string. So this overall string is now looking like this. So when we come back and try to use this, try to do our resume where we were, I think the strtoc functionality gets confused because it's expecting this null character and it's like, okay, let's jump to that, but somehow having an extra null character here confuses it, is what it seems. So one way to get around that, I don't know if this is a good way to get around it, but is replace undo replacing that null character. Either, well, copy in. Yeah, I guess using a copy is probably the best option. Passing into parse range. So can we do? What's the best way to copy? Isn't it like a stir copy or string copy? Now, what's the difference between stir copy versus string copy? The stir copy function is used to copy the source string to destination string if the buffer size of that string is more than I don't. Does it matter? Welcome. So copy destination pointer, copy from pointer, and that way we can pass in pointer copy and maybe not fuck up our entire world. Okay, closer. So now we're not messing up that string, yet like you can see they're the same before and after parse range, but we're still only getting one output. Why? Why are we still only getting one? Why are we only doing this loop once? Now if we let's get rid of all this, go back to the basics and just print out so now we're doing it 4 times, right? But if we add in some parse range stuff, oops, it then doesn't do it 4 times. So something is causing this loop to not work. But why and what? It has to be the parse range, right? Yeah, it is. Why though? Calling parse range messes up the loop. I thought having a copy here would fix that. I guess it's not. Well, let's see what happens. It's not being modified. Cool. What's going on here? Huh. Very, very interesting. Why is that? Why is that? For some reason, parse range. You're passing in this string, passing the start and end. Let's clear this. Parse range string is 1 to 2. It's gonna be something stupid, isn't it? Parse range. I'm kind of getting semantic fatigue now. Huh. So we do that, we come here, we come back, we print hardcore. It's not this is messing it up, right? It is. I'm gonna make. It clearly is just that's the issue, because if I remove only that, and then get a bunch of loop iterations. Am I ignoring something obvious? Possibly. I mean, this is the same. So I don't understand what's happening here. What is the problem? So strange. I'm a little stumped here. I'm a little bit stumped. Alright, well let's, I guess clearly it's going to be this logic that probably is the problem, but let's stub out parse range. Let's just stub it out and say start equals 69 and equals 70. I'm sure, yeah, I'm sure that's gonna work. Oops. Okay, we're getting 2 loops there. That's interesting. We shouldn't be getting 2 loops there. We should not be getting 2 loops there, because if we're working through a string like 1-2, should find that first one and then that's it, right? Because this should be null on the second one, right? Okay. Because if we have a string like 1-2, and we're saying, okay, string token, so this gets replaced with null. So then we say, all right. Well, no, we are doing 2 loops, because that makes sense because we're grabbing the 1 and then the 2. That makes sense. Replaces that. We go through, we say start -1. It is, so let's say start equals 1. Great. Let's say string token null, so we'd say, oh, you know what? Wait, am I even? I'm grabbing the right. Yeah, I'm grabbing the right numbers, so that's correct. That's the thing, I don't know what pointer copy actually is. If we're copying pointer copy into pointer, should be 15 question mark. So it's all nulls after that, which makes sense because, yeah, and that's fine because
when you're copying, it's basing that null character after the 2 as the end of the string, so it's not going to copy past that, and that makes sense. That's totally fine. You would think. Right? String length. Again, length, let's just do 15 just to see what it ends up. Let's remove some of these. Okay. Parse range. So yeah, we're replacing that, which makes sense. We're grabbing 1 and 2, makes sense. This seems to be working, makes sense. But yet calling it in here causes the code to not work. Causes the parse database logic to not work. Why is that? Why is that? Well, it causes this loop to not continue again. This is rough. Oops. So this is not working. Clearly pointer equals null, right? So pointer equals null. Why is pointer equal null though? That doesn't make any sense. Can we get rid of some of this up here? This seems to be fine. This seems to be fine. End of loop, pointer equals null. Oh, you know what's an easier way to do this? Pointer equals null. If it does, it'd be an equal symbol. If not, it'd be an exclamation. Pointer equals null. Why does pointer equal null though? We gotta be doing something really dumb here. Why does pointer equal null? A large one into a smaller one. I mean, the length of pointer is... The string length is 3. I mean, it's a 64. It should be. I would imagine we're fine, right? Oh, interesting. Oh, there's no null character. So we're copying into. Well, that shouldn't be an issue because, like, we're still allocating 64 characters because there's no character. String length doesn't know what the length is. That doesn't mean there's no length.
What the fuck? What the heck is the issue here, man? Okay, let's try not doing this. Okay, now still same result. String length is now 9, which makes sense. Wait, 9? 9? Nine? Now, why would it be a length of 9? Not specify the size of the destination buffer, so a buffer overrun. So we copy in based on the size of source. To copy a large into a smaller one is dangerous because it copies based on the source. But if the string will fit, then it will not be worth the risk. Using to copy a large character into a smaller one is dangerous, but if the string will fit, then it will not be worth the risk. What? The destination string is not large enough to store the source string. Okay, but it is in this case, because, well, why are we getting string length is, that's interesting. Let's see if that's consistent on a clean program. Interesting. So it's a still uninitialized memory though. That's the problem. If we were to, I mean, if we were to print hardcore, pointer copy, knowing it's between 8 characters, it's gonna be junk. It's gonna be garbage. It's random stuff. Oh, eventually we happen to have a null character there. Great. Because of that, it makes it think, oh, the string is, you know, 6 or 9 characters or whatever it might be. I mean, it's junk. It's random, right? We don't actually know. Again, I don't know why that means the earlier this issue is an issue. I understand that causes this to behave weird. So is like there a best practice for I mean, what you can do is say pointer copy equals a null character, and this will make that more consistent. Oh, sure. Well, we need a actually memset. Pointer starting address of pointer copy 0 number of bytes. Okay, sure. So now they're all 0. Oh, we don't really want zeros necessarily. Let's just do -7. Get some A's in there, yeah. Right. So now that makes sense. The length of the string that's stored in there is that. Sure, it's not the actual size of the buffer of characters, because if they're all null characters, it'd be 0. If the null characters right here, it'd be like 20. That's fine and dandy. That explains why string length was behaving weird, but like it doesn't help with why this loop is exiting early. That really doesn't make any sense to me. I just went on a wild goose chase there for a minute. Interesting. I'm a bit stumped now. Okay, let's get rid of this junk. Imagine this shouldn't be a problem. So end of loop, pointer is null. Yet if you comment this out, we'll get into the loop, pointer is not null, probably 6 or 7 times. Yeah, or however many times, not 6 or 7, 4 times, yeah. Well, let's just verify and make sure that every time we do this in here, pointer's address pointer's a string. Well, I want to wait, what? I want to print it as an address. So string pointer gets incremented, which makes sense because you know, that's the whole string token thing. String stays the same, which is what you'd expect. Nothing's changing there. As far as over here, database string pointer and pointer copy. So our database string is this guy that shouldn't change at all. Our pointer is this. This is our pointer within oh, maybe I can just do this to make it get rid of those warnings. Cast it as a void pointer. Unsigned int.
45. Oh, it literally just needs to be an unsigned int. What? Oh, sure. Oh man, we're still... Okay, maybe we don't do it that way. We'll go back to what it was without casting anything. Because I just want to see the address in a kind of string readable format. No such clear... What? Oh. Okay. So, database string is at this point in memory. Pointer initially points to the same thing. Sure. Pointer copy is a completely different thing, as you'd expect and want. Within parse range, string is here and then here. String stays the same. Pointer then gets incremented off of based on the original. That all seems to check out. That all seems to check out. So what the heck is the problem? I think it's a good opportunity to take a 10-minute break. I will be back, potentially.